Okay, this is section 812, or notes number 9 here, working with interior angles of a polygon. Now, the interior angles are the ones inside the polygon. Alright, so we're talking about these guys, the ones with arcs. Those are interior angles, and I'm going to give you a brief preface on things called exterior angles as well, which are not these, by the way. They are on the outside, but here we go. Okay, we know that triangles add up to 180 degrees, the interior angles, that is. So these three, that plus that plus that, they add up to 180. Let's figure it out for any polygon, and I mean a four-sided one, quadrilateral. We know that's 360. Pentagon, hexagon, etc. This was on your exam, but I just want to make sure that we get it totally covered. So we'll investigate the angles, and we'll do this using, first of all, a regular pentagon. Now, before I continue, I do want to make sure you know what regular means, and it's the same as a square and an equilateral triangle. A regular polygon in general is ones with congruent sides and congruent angles all the way around. So a regular pentagon will have all 5 sides congruent. If one side is 6, the rest is 6. And if one measure is, well, something, the rest are the same thing. So I want you to quickly think here about what they might have to add up to. I'm sorry, that's what we're going to figure out. So let's figure out here what the interior angles will have to add up to. And it's not 360. I mean, and you can think about that right now when you start taking these pentagons and adding them together. The triangle is 180, and a quadrilateral is 360. So a pentagon, whether it's regular or not, let's try and find the sum of these interior angles. It says, hint, you may want to use the fact that the sum of a triangle is 180 degrees. So it might be wise, and I'm going to use black to work with this thing, but it might be wise to go ahead and divide these into triangles. Take these and make these. So I have, although I have bad lines here, I do have 3 triangles. If you can see them, here's one. Let's call this 1, 2, and 3. Triangle 1, triangle 2, and triangle 3. Now, all triangles add up to 180 degrees. So I don't know what the degree measures are, but the fact of the matter is this plus this plus this equals 180. This is 180 degrees of measure. Here's another 180 degrees measure. This, this, and this. In triangle 2. In triangle 1, here's this plus this plus this. So I don't know what the measures are, but I do know that they add up to 180. So if those add up to 180, then this is a specific measure. So is that, so is that. I add them all up together, and I get this degree measure, whatever it is. So the point is, I can add up every degree, whatever they are. Since all of them add up to 180, I can do 180 degrees plus 180 plus 180. I'm not going to spend too much time looking at different ways to do this, at least not for now. That's 360 plus 180, which, careful with your math here, but that's 540 degrees. So the angles of a regular pentagon, the interior angles, or of any pentagon for that matter, add up to 540 degrees. Okay. Yeah, and I'm not going to work with different ways for now. There are other ways that I can do it, using exterior angles. But I don't know if we've done enough yet to go over that. As far as an understanding through an investigation. I'll just have you trust me for now as far as what we've done to figure out 540. Remember, adding up the triangles. Or I could have taken off one of these here and just said, here's a quadrilateral that's 360 degrees. Here's a triangle that's 180 degrees. That still adds up to 540. Okay, sum of all the interior angles of any polygon. So let's keep going up with this count here. We have a triangle is a 3-sided shape is 180 degrees, sum of the interior angles. Quadrilateral is 360. Let me go with a smaller pen here. A quadrilateral is 360, and a pentagon we now know is 540. Okay. 3 can create a pattern here, and we see that it's linear. Every single time I'm increasing 180 degrees. I'm not here you can also say I multiplied by 2, but here I didn't multiply by 2. Here I added another 180. So you can kind of make an assumption, make a conjecture, make a prediction that when you go up one more side or number of angles or whatever kind of shape it is, you're going to add another 180 degrees. So maybe it's time to take out your calculator, or if you've done enough with like skateboarding and snowboarding, then you know that, you know, then you start learning these angle measures. So just go with me here. I think it's 1260, 1440. 1 second. Just lost my count. 1260. Now be careful here. This goes from 10 to 12. Okay, so after that is 1620 and then 1800. So think of rotations on a snowboard or whatever. I don't think anyone's going to do 12 spins out there. So you'll see every single time we are adding 180 degrees for every new side. Now the question is, does the interior angle sum depend on whether the polygon is convex? So draw some non-convex polygons in your paper and determine if it matters. I'm going to go ahead and just use the one that they gave us. And let's start by dividing this into triangles again. Now, first of all, count the sides. 1, 2, 3, 4. So four-sided shape. I'm going to make a triangle out of it. This triangle adds up to 180. This triangle adds up to 180. 180 plus 180 is 360. Not 306. 360. For a four-sided shape, that sounds good to me. Yeah. So does it matter? No. No, it should not matter. Okay. All right, here's part C for that previous problem, so make sure that you remember what we're talking about, interior angles. So as I go on, and I'm going to actually refer to this table here, so take a close look at it. Find the sum of the interior angles of a 100-gon. What that means is a 100-sided polygon. And that almost looks like a circle, too. That'd be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like, you know what I mean. It gets pretty rounded. There are a lot of things in there. Explain your reasoning. Okay, well, if you think about what this pattern shows us here, and I'm going to start here by looking at it. Every single time we add up another 180 degrees. Okay. Now, this is a linear slope. In other words, I'm taking something, multiplying it by 180, and then I'm getting this. Okay. Imagine for a second, if you will, that instead of these numbers were 1, 2, 3, 4, 5. Okay. Could you come up with a kind of an equation that would represent this? And that is to say, what am I multiplying this number by to get 180, or this number by to get 360, etc.? And the answer is, if you look at it, I multiply 1 by 180, and I get 180. I multiply 2 by 180, I get 360. I multiply 3 by 180, I get 540. 4, and etc. So if I multiply this number by 180, then I get the angle measure. So if I called that x, if this was 180x, that equals the degree measure, if that makes sense. The only problem is 1 isn't anything in terms of 3. Like we're looking at a triangle, and I just multiplied it by 1. And a triangle has 3 sides, so that doesn't really make sense. Same with the quadrilateral. How does this 2 come into play? So that's where there's kind of a hiccup here. So we have to figure out, what else do I have to do? Like, how does this x come into play such that I'm multiplying a triangle by 1 and a quadrilateral by 2 and a pentagon by 3? Well, as you can look, I mean, I crossed out the numbers, but how much greater is 3 than 1? 4 than 2, 5 than 3, 6 than 4, 7 than 5. They're always 2 greater. So I take this number 3 here. If I subtracted 2 from 3, I get 1. And then if I multiply it by 180, then I get the number of degrees. I subtract 2 from 4, and I get 2. Then I multiply it by 180, and I get 360. I subtract 2 from 5, then I get 3. I multiply it by 180, I get 540, etc. So this keeps going. There's a pattern here. So let's say, and hopefully that's starting to make sense. And if you have more questions about it, just let me know. Let's say that n is my number of sides in the polygon. And remember, it's also the same number of angles, sides or angles. Okay. And let's say that d is the total degree measure. By the way, if you ever hear a long moment of silence when I'm talking, that's because my I have this headset, and I'm still trying to figure out how it works. It's turning off on me, and I have to turn it back on. Anyway, if d is my degree measure, I'm going to use this to first make a conjecture. I'm not even talking about 100n. I'm talking about an n-gon. If I have an n-sided shape, how do I get the degree measure? Well, remember, if I take the number of sides, like 3, a 3-sided shape, if I subtract 2 from 3 and get 1, multiply 1 by 180, I get the number of degrees. If I take a 4-sided shape, subtract 2, I get 2. Multiply by 180, etc. So if I take the number of sides, n, whether it's 3, 4, or 100, and I subtract 2 from it, I take n minus 2 and multiply that by 180, then it appears, through that pattern, that's a multiplication by the way, that I get the number, or that I get the degree measure. So the degree measure is taking the number of sides, subtracting 2 from the number of sides, and multiplying by 180. That's just recognizing it through a pattern. So a 100-gon, I take 100-sided shape and subtract 2, multiply by 180, I'll get d. So that's 98 times 180. I actually don't have a calculator in front of me. Why don't you do that one on your own to finish up? Well, actually, no. Here, let's do it this way. Let's do 100 times 180 and then subtract 2 times 180 from it. So 100 times 180 is 18,000 minus 360. So, hey, we've done math before. 6, 7, 1. So this is how many degrees a 100-sided shape is. 1,000 or 17,640 degrees. Okay. All right, the pentagon at right has been dissected into 3 triangles with the angles labeled as shown. Use the 3 triangles to prove that the sum of the interior angles of any pentagon is always 540. So before we talked about a regular pentagon, meaning all sides congruent. Here, this time, not all sides are congruent. So we're going to have to figure something out with that. What we can do with each interior angle. So no matter what kind of pentagon it is, if it's regular or not, just like a quadrilateral versus a square, it still adds up to 540. I don't know what each individual angle measure is, but I know that it all adds up to 540. Okay, but let's find each individual angle measure in terms of these letters. Like, here's angle W, or VWX, or whatever you want to call it. Substitute the 3-letter name for each angle of the pentagon, and for the lowercase letters at each vertex. For example, measure of angle XYZ, that's this guy right here, equals C plus E. Okay, and that makes sense. Here's C, here's E. That must be this angle right here. So let's do it for the other 4. I'll do it for WXY, which is the easy one, because it just equals B. Actually, same with this V right here. You could use a 1-letter assignment. Like, I could have just called this angle V. Okay, continuing on, let's get angle W, this big one. I'll call it XWV. I'll try and work quickly because they're going to come back. So angle XWV is A plus D plus G. Check that out, A plus D plus G. And finally, Z, or VZY. Angle VZY equals I plus F. And then they did Y for us, XYZ, which was C plus E. Okay. Use angle relationships in each of the diagrams below to solve for the given variable. You have to first count the number of sides and figure out what the interior angle is, or what the count up all the sides, figure out what the polygon is, then figure out the measure of the sum of the interior angles, and then figure it out based on that using some algebra. So this is a 1, 2, 3, 4, 5, 6, 7-sided shape. And you can even refer to your chart here. 7-sided shape adds up to 900 degrees. So all of these together should add up, all of these together should add up to 900. So I have 138 plus 106 plus m minus 9 plus m plus 133 plus 120 plus m plus 13 equals 900. So now it's up to you doing some algebra here. M plus m plus m. So I have 3m over here I have 138 plus 106, which is 2, gosh, I have to go through this, 244 minus 9, which is 235, plus 133, which is 235, plus 368, I might screw this up, plus 120, which is 488, plus 13, which is 501. No, did I say 4? Yeah, 488. Okay, I hope I said 488. Plus 13 versus 501 is 900. So plus 501 equals 900. I might be off on that, by the way. 3m equals 399. No, that looks like that should divide. M, so that's 300. So it's 100, 133. So m is 133. And remember, that's not a degree measure. Now, here it is, technically. But it's just, it's a unit. It's not like I solve for one angle. I solve for what I could figure out, what the other angles are. This is 133. This is 133 plus 13, which is 146. And this would be 124. And this is 133. Okay, hope that makes sense there. This is a hexagon, a six-sided shape. And a six-sided shape adds up to, here's the 6, by the way. I'm looking at that right here. Adds up to 720 degrees. Now, these are all x's. You can either assume that all these should be the same thing. So if there are 6 angles all the same, you can do this one of two ways. Add up all the x's and get 6x equals 720, then divide by 6. You get x equals 120. Or better yet, just say, in a 720 degree shape with 6 congruent sides, you have to divide by 6 to get one individual one, because they're all the same. So divide by 6, x equals 120. So I'm going through this a little quickly here. All right, here you have to do a few more steps to find k. Check this out. Equilateral, or isosceles triangle. So they have opposite congruent angles right there. So if they're both opposite, I'm going to call these x for now. 64 plus x equals 180. Notice how I wrote that both of them are x, and I know that because they're both the same. Whatever they are, they're both the same. So subtract 64, combine x's, you get 2x equals 116, x equals 58. So these are both 58. This is 90. Okay, but 58 plus 90 is 148. So here's 148, here's 58, plus something else equals 180. That doesn't technically matter. This is all 180 here. So check that out. I mean, it doesn't matter because that's not an angle. Okay, now we have our angle measures. 64 plus 148 plus 96 plus k plus 88 equals a 5-sided shape. 1, 2, 3, 4, 5. So you see that? 5-sided shape. By the way, my headset turns off every 5 minutes, I think, because once it's inactive, it doesn't hear any noise. It shuts off to reserve battery. Despite the fact that I'm talking into the mic, it doesn't recognize that it's hearing anything inside that headset. So I'm looking for something that equals 540 degrees in solving for k, because of 5-sided shape, a pentagon, if you will. So 64 plus 148 plus 96 plus 88 plus k equals 540. 64 plus, I'll do 196 first. That's 160 plus 88 is 248. It's a k, by the way. 248 plus 148 is 396. So 396 plus k is 540. All right, turned off on me again. So that's 144. Subtracting 396 from 540. Okay, it's 144. Okay, last one, I gotta go. Okay, 1, 2, 3, 4, 5-sided shape. Alternate interior angles. Whoops, that's not alternate interior angles. Alternate interior angles congruent here. Okay, now this is not a part of my inside angles, but if I figure out what that is, then I'll figure out what that is, and I'll figure out what that is. So let's see what we do have. We have a 5-sided shape that adds up to, oh, well, I'm sorry. You know what? We do have our same side interior angles. Here we go. Same side interior angles. So both of these add up to 180, whatever they are. And honestly, I don't care what they are. It doesn't ask us to figure out what that is. It asks us to figure out what y is. So these add up to 180, if you can see that. Same side interior angle. So I have 180 plus 135 plus 2y plus 3y. Now remember, this, even though it's 4 numbers written, this represents 2 angles. So this is a 5-angled shape, a pentagon, which we just did adds up to 540. This adds up to 540. Combine like terms, I get 5y plus 315 equals 540. 5y equals 225, subtracting 315, and y equals 45 right there. Okay? I should stop putting degrees because I don't know if it's technically degrees or not. But y is 45 there for that reason. Same side interior angles add up to 180. So this plus this is 180, plus this, plus this, plus this. Total equals 540 because it's a pentagon. Okay, so there's your practice. And I hope this came through right. I have to do some making sure that all this came through. And if you have any questions, let me know.